The first type of thunderstorm we're going to cover is the single cell thunderstorm. You may hear this referred to as a pulse storm or a garden variety storm. Typically, the single cell storm in its mature stage lasts about 20 minutes. It consists of one single updraft. And generally with the single cell storms, we expect small hail, gusty winds, and heavy rain. The severe threat usually is quite low with the single cell storm, although we can have a brief period of large hail and isolated damaging wind gusts with the single cell thunderstorms. The following radar loop from the Peachtree City, Georgia radar shows an example of several single cell storms. And again, these are typically very short-lived cells that have a very low severe threat, although we can get brief damaging wind gusts or large hail, but overall a very low severe threat with this type of storm. The next class of storms we're going to look at is multi-cell convection. Now these multi-cell storms are probably the most frequent producer of severe weather in our region. On the left we have hazards of wind, hail, heavy rain, and tornado broken down, and the threat level with each of these hazards when dealing with multi-cell storms. Wind and hail we have in the moderate threat level, heavy rain in the high threat level, and tornadoes in that low to medium threat level category. Unlike single cell storms, multi-cell storms have several updrafts, not just the single one we saw with the single cell convection. An interesting aspect of the multi-cell storms is that cool front or gust front that develops from the downdraft that can kick off new storms and create a larger cluster of storms and a longer duration, more organized severe weather threat. Flash flooding is possible due to the slow movement of the storms and the continual regeneration of storms with that gust front. Really, the whole range of severe weather is possible, including downbursts, straight line winds, small to medium-sized hail, and of course lightning. Here's an example of what you would see with the multi-cell convection if you were looking to the west-northwest. You see several individual updrafts. Your strongest storm is your most vertically developed, with these very sharp cloud tops indicating a lot of ice or supercooled water in the cloud. But we can see other strong updrafts located back to the southwest of the original updraft, and your newest cell here with least vertically developed, but still showing those sharp tops to the cloud tops here, indicating a lot of supercooled water or ice. So you can see here just several individual updrafts in a more organized system. Looking more in depth into the multi-cell storms, there's a particular type of multi-cell storm, the squall line, which we're going to look at here. The squall line is unique because it can be associated with especially a damaging wind threat, medium to large sized hail, lightning, even isolated tornadoes possible along the leading edge of the squall line, and even tornadoes, but they're usually weak and short-lived if they do occur with the squall line. In the diagram here, the red arrow indicates the updraft. Typically, these are typically associated with a cold front advancing east. You get a very strong updraft at the leading edge of the cold front. But that strong vertical motion causes precipitation to fall and it creates that rain-cooled downdraft. And a unique aspect of the squall line is you get this very strong updraft in very close location, proximity to this strong downdraft immediately behind that gust front. The overall threat level with each of the hazards of hail, heavy rain, wind, and tornado. We list hail as a moderate to high threat, heavy rain is a medium threat, wind is a high threat, and tornadoes in that low to medium threat. The following represents a radar image of an example of a multi-cell squall line that affected northeast Illinois and northern Indiana. What I want to point out is just the linear feature of the squall line and the linear feature of those higher reflectivities in the darker oranges and reds as they move from northwest to southeast. What you can expect is strong winds, possibly damaging winds, may precede those higher reflectivities in the higher rainfall rates. And briefly after the onset of those stronger winds, you could expect heavy rain, possibly some hail as that squall line moved through. The image on the right is what you might look at out ahead of this squall line. We'll cover this in a later section. This is an example of a shelf cloud, which is often associated with the squall line. And we'll get into more details on exactly what causes that shelf cloud to form. But when you see this type of shelf cloud that expands the whole horizon, that's typically an indication of a damaging wind threat with a squall line type feature. And if we look at an extreme case of a multi-cell squall line, we're talking about derechos. These are multi-cell storms in the form of a squall line that's very organized, has a very long lifespan, and is associated with numerous and widespread reports of damaging wind. Here's an example of a derecho SPC storm reports from late June 2012. Everywhere you see a blue dot on this map is a report of damaging wind with this event, and everywhere where you have a black square is where you have very high winds of 70 miles per hour or greater. For this particular event, you can see in our area these damaging winds began in northwest Indiana and persisted and became widespread through northwest Ohio and even lasted all the way into the mid-Atlantic states. So this is an upper end case, an extreme case of a squall line, the derecho, which caused widespread damage, wind damage in our area. And now just looking at a radar overview of that late June 2012 case, you can see how the storms initiated there in northwest Indiana, and it developed into a squall line and then into eventually a derecho, which produced widespread damaging winds all the way from northern Indiana into the mid-Atlantic states. But again, you can see as that formed, you had that linear squall line type feature, just became very large scaled and produced widespread damaging wind. The last type of thunderstorm we're going to look at is the supercell thunderstorm. Now, the overall severe weather threat level for hail, heavy rain, wind, and tornado with the supercell we have listed as high. That's because the supercell is the most organized of all the different thunderstorm types we've looked at. In the image here, we're looking at a schematic of the supercell structure and what the supercell storm may look like. In this case, we're east of the storm looking to the west. On the left part of this image, or looking to south here, we see that the clouds have no rain coming from the base of those clouds, and we call this the rain-free base because the updraft is strong enough to keep the precipitation suspended aloft. Now where we have this isolated lowering of the rain-free base, we'll talk about this more in depth later, but this is the wall cloud. That just represents where your updraft is the absolute strongest. And that's important because where this updraft is the strongest and where your wall cloud forms is where you're most likely to have a tornado form if it does form. Looking on the right side of the image here, or to the north, this is where we have a lot of our rain and or hail falling from the storm. So because we have rain and hail, this is going to be downdraft dominated, not so much a tornado threat, but a damaging wind threat possible here along with hail and heavy rain. And it's important to understand when conditions are favorable for supercells, because not every supercell does produce tornadoes, but supercells are responsible for the most significant tornadoes in the United States. When we talk about very large hail, larger than golf balls, typically we're going to be talking about supercell storms. So it's important to know the days when supercells are expected, because this can be associated with some of the higher end severe weather events.